So number 6 on worksheet 1, if A is 18 and B is 10 square root of 2, then cotangent of A. Okay, so if we're looking at A, that sets who's opposite and adjacent. If we're looking at angle A, then this side is opposite and this side is adjacent. So cotangent, let's see, tangent is opposite over adjacent, so that means cotangent is adjacent over opposite. So 10 root 2 over 18, which reduces to 5 root 2 over 9. So number 1 is true. All right, statement number 2. If C equals 5, okay, so now I need to be careful. I'm going to mark out my previous problems. If C equals 5 and A equals 2 root 2, then secant of A, okay, so we're still looking at A, that still means this side is opposite, this side is adjacent. Secant goes with cosine. Cosine is so toa, so that means secant is h over A. Again, I don't memorize the weird ones, the new ones. I really don't have those memorized. I only have their partners memorized, and then I flip it. So cosine is A over H, which means secant is H over A. So H is 5, the hypotenuse. Adjacent, I don't know. So what do I have to do to find the adjacent side? I know two sides. Yeah, Pythagorean theorem. So 2 root 2 squared plus b squared equals 5 squared. So 25 minus 2 root 2 squared would be 4 times 2 is 8. So b is the square root of 17. So adjacent is square root of 17. So I don't know what this is. I mean, I guess I should fix it, but there's no way I'm landing at 5 root 2 over 4. So number 2 is not true. Statement number 2 is not true. All right, statement number 3. If A equals, start over one more time, square root of 3, and B equals square root of 5, cosecant of B. Uh-oh, I got to be careful now. I'm looking at B. That changes who's opposite and who's adjacent. So this is a messy problem because you keep writing over your own work. Cosecant goes with sine. Sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. Opposite of B is square root of 5. Hypotenuse I don't know, so I've got to do the a squared plus b squared equals c squared thing. So c is the square root of 8, which is 2 root 2. If I simplify that. And then that doesn't look like my answer, but I need to fix it. So I get 2 square root of 10 over 5, which is not the right answer. It's close, but it's not it. So only number 1 is correct. All right, so we just did 3 problems in 1. What else? Let's do a couple more. Yes, sir.
I was just confused on the answer you got for number 9 in this one.
Okay.
Mine was 12, but it's just decimal.
Okay, let's do it and see what happens. Number 9. And maybe the key is wrong. We'll see. A 24-foot ladder. Okay, this gets people sometimes. So the ladder is 24 feet long. So where do I label 24 on the picture?
The slant.
Yeah, the hypotenuse or the ladder is 24. Positioned against a vertical wall, forms an angle of 75 degrees with the flat ground. Okay, so the ladder makes an angle with the ground of 75. How high up the wall does the ladder reach? I guess we could call that H. Okay, let's see. A squared plus b squared equals c squared doesn't help. Adding up the angles, I mean, yeah, it's 15, but that's not what we're looking for. So this is a SOHCAHTOA problem. And if it's SOHCAHTOA, that means you pick the angle and then pick the ratio. Well, the angle's going to be 75. That sets whose... Oh, I shouldn't label that H, right? That was a bad choice.
Well, it's whatever.
I mean, it doesn't matter, but H is usually hypotenuse, so I'm going to change that. I don't like that. I'm going to just call it Y. But you can call it H if you want to. I just careful with hypotenuse. So now I know who's opposite, who's hypotenuse, and who's adjacent. So I know the angle, so I'm good with sine, cosine, or tangent because I can punch those in the calculator. I want to find opposite, and I know the hypotenuse. So if I'm using opposite and hypotenuse, which trig ratio should I use? That would be sine. So sine of the angle, always, always, always sine of the angle, equals opposite over hypotenuse. So y equals 24 sine 75. 24 sine 75. Make sure you're in degrees. 23.182.
Yeah, you have like 3.05.
It was 23.070.
Hmm.
Yeah, it was something weird.
I apologize. It should be 23.182. I wonder if I did that in radians. Nope, that would. That's definitely not right in radians. Yeah. Apologies for that on the key. I don't know what happened. This would be one where if you were in radians, you would catch the error right away, I hope, because your height can't be -9. That doesn't make sense. So if you get an answer that's weird, check to make sure you're in degrees. The trouble is, radians won't always give you a weird answer. It might give you an answer that makes sense, so it's not a foolproof thing. But sometimes it'll give you a weird answer and you'll catch it. Again, on test day though, somebody needs to remind everybody, and it might be me, but if it's not, one of you needs to remind everybody to make sure their calculator is in degrees. Anything else? We get two of them. Well, one of them really counted as 3 problems. And some of the others are pretty straightforward. All right, so take the rest of the time to finish it if you haven't already, and then study for whatever else you got going on today.